All right, welcome everyone. Today we will be having another seminar by Kim Warren. This is part of the seminar series to elevate your business strategy. It's the system dynamics for business innovation. Kim Warren from Strategy Dynamics has done several of these seminars throughout this year, and they are available on our website in the seminar series. The recordings are also available for all members and can be purchased separately if you're interested. So today's topic is going to be how to build a dynamic business model fast and reliably. Okay. And I just want to also mention that we have our upcoming conference. It has changed locations to Boston. So that is going to be from August 3rd through 7th next year at Boston University. So we hope you can join us there. And then also we want to give a shout out and thank you to our sponsors. These are our society sponsors and our university collaborators. They help make these seminars and other activities that the society does possible. So we want to thank them so much. So today, the agenda is going to be a 90-minute modeling exercise. This is actually going to give you practice in building these models. So along with that as well. So our speaker is Kim Warren, who has decades of experience in business consulting and the business world. He has a consulting organization called Strategy Dynamics, and he has been doing amazing work. And I also want to mention there is a certificate for those who have gone through this business dynamics seminar series. You can get a certificate of completion at this link. You can request your certificate through the form, and you'll need to include at least 6 attendance codes from these meetings. By watching the recordings, you can copy down those codes and include those in order to get your certificate. And I also want to mention that for all who are joining us today, we are offering a 30% off discount on your first year of membership. And this is available for all membership tiers. This is for those who are participating in this seminar series. And this is valid until the end of the month, November 30th. So copy down this coupon code if you are interested in joining and becoming a member. All right. I will let Kim take over. And Kim, you can share your screen now.
Okay, thank you, Megan. Hi,
Yes.
everybody. I'm so pleased you could make it to be with us here today. Megan, please jump in at any point if things go pear-shaped and let me know that something's gone wrong. I'm trying to spin I'm trying to keep a lot of plates spinning this afternoon, so this is going to be a bit of a roller coaster ride. First of all, can everybody see the slide? Yeah.
Not yet. I think it's still black.
Whoa, okay. Let me stop my video. Maybe that'll help the bandwidth issue.
Now I can see it. Can everyone else see it?
Right.
Yeah.
Okay.
Great.
Yep.
Okay.
Yes.
I will try to pause for questions at various times this afternoon, but this is a really big agenda which I'm trying to get through today. So I hope this is going to come off okay. First of all, there are slides for this seminar, both PDFs, but I think more useful to anyone following this will be the PowerPoint slideshow, because what that does is it builds up every actual step that you take. So if you follow the first link, you'll get the PDF. If you follow the second link there, that will give you the PowerPoint slideshow that will actually play things out for you. I'll leave those links on the screen just for the next couple of slides. Um, Another thing to say is, well, let me just start by explaining who this seminar should be useful for. And many of you will know that I've spent an awful lot of time trying to bring these models, what they can do, to the attention of senior leaders in all kinds of organizations. So if you happen to be such a senior leader, or if you want to share this um, video with senior colleagues, then I hope you will see just how powerful these digital twin business models can actually be. And um, if you are a senior person, you won't be building these models yourself, but you should be reassured that the people who work for you, whether they're internal support staff, accountants, or whoever, or external consultants, it's a perfectly possible thing for them to do, to build these models for you. So they're both powerful and doable. You can actually do this thing. If you yourself are an analyst or a consultant or an accountant or a student trying to learn about business or about models, I hope you will understand at the end of this and actually be able to practice what I think is a pretty reliable and kind of rigorous four-step process for building one of these models. I've given it this little brand name, Agile SD, for reasons that I hope will become apparent as we go on. The other thing just to mention at this point is that there will be a lot of people on this call who don't know anything about all this stuff. So if any people on the call are system dynamics people and say, yeah, I know all this, why are we wasting time on that? But just bear in mind that not everybody knows what you know, right? So we're trying to make this accessible and understandable for those people. And secondly, if I've done this okay, and I've done it, I've found a way of communicating this to people, you may find it useful yourself to communicate how these models are built and how useful they are to other people by following the same kind of story that I'm going to take you through here. This I've mentioned in previous seminars. We've kind of got a little bit of a mindset that you use models to answer big questions, but you can do a lot of other things with these models. Yes, we can use them to build models of business strategies and plans. I have built with clients complete business plan models to enable not only to see whether the business model that they have in mind will actually work in the first place, but also actually to manage that business as it starts going forward. So use the model week to week to check how things are going, to test out uncertainties, to try strategy options and changes to, well, even to practice simple things like, should we do this marketing plan next month or the month after? Simple questions like that. They can be used for functional strategies. We happen to be focusing a little bit on a kind of marketing oriented case today, but there are functional strategies and plans in staffing, in product development, and so on. In fact, we have one of the previous seminars in this series is specifically about using these models for staffing purposes, HR strategy issues. You can use them for new ventures. Test out your business model before you try it. It's a particularly promising use for these models because new venture models tend to be relatively clean and simple. We're not trying to model all the complexities of Google or something when we're doing a business model for a new venture. And when we're taking big initiatives like making an acquisition or launching a new product or something, then we can model just that episode from kind of before it starts right the way through its implementation. And then we can use it for very local issues and often quite short-term issues. We've got a service quality problem. What are we going to do about that? We've got a staff turnover problem. What are we going to do about that? So those are the kinds of purposes that we use these models for. Now, so how are we going to do this this afternoon? Well, it's afternoon here. It may be morning for you and on the other side of the Atlantic. But so basically, the plan is this: I will try to explain. I will explain a key principle that we're following at a certain point in the process. And then I'll switch over and actually show you how to implement that principle in a particular step of actually building a model. Now, you can, first of all, you can get the models. And I will give you some details in a moment on how to get the models, and you can follow each step. Now, if you're going to do that, you're going to need two screens, one to watch what I'm saying and the other to actually do what I'm saying at the same time. If you have not got two screens, then it's not all lost, because you can go through the same process just following the slideshow at a later date. If you've got the slideshow, you can go through that and do exactly what I'm showing in the in this seminar. You can download the recording, and again, you can just copy the thing there. So at any time, you can keep coming back to it if you just want to go through it slowly, step by step. Spend half an hour on it here, half an hour on it there. So you can follow this. And return to the recording anytime to do the thing again and just check out particular details of what we've done. Now, if you try to follow what I'm doing here this afternoon, you will almost certainly get behind at certain points. I will try not to go too fast. I will try to do it very clearly and simply. But again, you will have the recording, you will have the slide deck, and you will have the models built up step by step, so that you can follow it again later. The other thing to say is there's much more content in the slides than we can cover. So at various points, I will quickly run through slides that we don't have time to go into detail on. Okay, but just to reassure you that the detail is there, and you can come back to it in the slideshow itself. So first of all, how to get the models and how to use them. We're going to have a series of about 4 or 5 models. They're all, model 2 is model 1 plus a bit, and model 3 is model 2 plus a bit, and model 4 is model 3 plus a bit. That's how it's going to work. And the models run in an app called Silico. It's a browser app. You haven't got anything to install. And all of the models are in a single, what Silico calls a project. A project is a set of models that share common settings. So if you go to the link that I've shown there, sdl.re/build model, that model, the model we are going to use, should open in your browser. I'll say a little bit more about what that looks like in just a moment. Later, or at any point you want, you can save your own copy of the project and your own copy of the models that are inside that project by creating a free account on the Silico app. And when you try to save it, it will send you to the place to create a free account anyway. But that's where it is. It's being hosted by a business called pathforward.io. Okay, so if you go to that link, this is what you should see. I may take this step particularly slowly just to see if it is actually working. Let's have a look. If someone could say on the chat, maybe just let me know, has this thing actually opened in your browser? That would be helpful. Whee! Excellent. I've at least got one yes, so I'll take that as a success. Okay. Now, so when you click on that link, the project access page opens. This isn't the project itself. What you then do is click on that little link there, Explore Model, and this is the screen you should see. So this is the browser window, and it shows you the project. The project is now open in your browser. You can do what the heck you like with it. Any changes you make, it's up to you. You can mess it all up, or you can improve it massively. It's now yours to do with as you want. So if you're following the modeling steps, you should now have the project open in your browser. Is that going okay? Let me see. Yeah. Has that worked? Hey, that's another yes. and another S. Hey, fantastic. Oh, that's great news. Whew, that's my first little worry here. Now, this is one of those slides I said I was going to go through very quickly because we don't have time to go on all this detail, but it's there in the slide show. Here's a quick guide to what you're looking at. Okay, that big white space in the middle of that there, that's the workspace where you build the models. On the left is a list of the models that are in this project. And you can see that they go numbers 1 to 4, which happen to match the steps in the process that I go through. And then there's a couple of others at the end. If you want more space, there's a little double arrow thing here. I don't know if you can see my cursor here, but there's a little double arrow where you can collapse that side panel to give you more space. At the bottom, there's a time bar where you can see where you are in the model. And by default, you are always at the end of the modeling time. I'll say more about the modeling time in just a moment. You can create scenarios at the bottom left of that panel. If you click on the Silico word at top left, that will take you back to, if you're in your account, it will take you back to any other models that you've created. We sometimes need to change or set the project time settings. We will do that in just a moment. You can save the project to your cloud account. This app works by creating for you a cloud account where your models are saved. And the first time it will prompt you to open that account. And at the top right, there's a version history. Every time you hit the save button, a copy of the model is saved up to your account. And you can go back to any previously saved version by hitting the version history button at the top right there. So what are we going to do? We've got the preliminaries out of the way. I'm going to start by giving you a very short summary. This is kind of a roadmap of where we're going this afternoon. I'm giving you a quick summary of what this 4-step modeling process actually is. And I'm going to introduce a case example that we're going to use. And I'm then going to go into kind of demo mode. And in demo mode, what are we going to do? We're going to show how to set the timescale for a model. We're going to explain the 4 steps of the process, how outcomes change over time, and so on. I'll say more about all these in a minute. And after I've done all that, we'll come back and explore a future strategy for the case example that we've modeled. We'll discuss what I think are some quite substantial benefits of the process we've just been through. And for those of you who come from a heritage in the system dynamics world, I will highlight for you how this connects with a kind of feedback loop view of how the world works and how we build models. So let me start with this summary of the 4-step Agile SD process. Now, anyone who's built models using system dynamics in the past, I should highlight for you that this is a very, very different process from how most of us were taught to build system dynamics models, including me, right? This is not how I was taught to build system dynamics models, whether for business or any other purpose. But when we get to the kind of last but one item on the agenda, I will try to highlight for you what I think are some quite substantial benefits from this approach compared with how we've traditionally gone about building these models. So here is that process. We start in the same place we always have done, which is by putting a kind of chart on the whiteboard, or in this case on the computer screen, of what the desired outcomes we want from whatever situation it is we're trying to improve. And that includes some history for reasons that are important, and I will explain in a few minutes. What we then do is we ask what causes those outcomes, but we're not kind of asking here for people's opinions. We're asking here for evidence. We're asking here for simple, local, and concrete explanations for those outcomes. What do I mean by that? I mean that we want an explanation in the form of, I can calculate A if I know B and C, right? It's as local and specific and you might feel initially relatively trivial as that. Step two is, if you keep asking that question, what causes those outcomes, you bump into really quite quickly one or more things that we call stocks. System dynamics people, please forgive me. Not everybody on this call knows what a stock is, but I will explain what that is. It's a quantity of something that drives the outcomes. Very simple examples. Customers drive our sales. Staff drive our service support. Staff also drive our labor costs. Okay, customers and staff are things we call stocks, and you can calculate in one or more steps what sales are if you know how many customers you've got. You can calculate what your labor costs are if you know how many staff you employ. You can calculate how much service support you can offer if you know how many staff you have. Okay, that's step two. Step three is that those stocks of things fill up over time, and they fill up because things called flow rates add to them. So if you want to know how many customers you've got, you need to know how many customers you had previously, how many you've won and how many you've lost. If you want to know how many staff you'll have next month, you need to know how many you've got now, how many you will hire during the next month, and how many you will lose over the next month. Turns out this is a universal feature of all real world systems, but it is step three in this process. We then ask that same question again, what causes those things? And what that discovers is that there will be other stocks of resources that cause those flow rates to happen. So why are customers won at that rate? Well, because I've got a certain quantity of salespeople who call on customers at a certain rate. Now, when we got to that point, we will have discovered some more stocks. So what we've got to go do next is go back round step 3 and 4, which is to identify the flow rates and ask what causes those. You rarely have to go around that loop more than 2 or 3 times before you've got a satisfactory explanation for why the situation is behaving as it is and where it will likely go into the future. If you then add a visual quantifying simulation tool to do all of that, then you end up with a living, dynamic, we call it a digital twin because it matches the real world, a model of that situation. Now, the process I'm going to take you through this afternoon is completely independent of what software you use. Any OK system dynamics software will allow you to do this. Some of them have got some limitations, but you can work around those limitations. But this is a method I'm explaining to you. I'm not saying this is only something that you can do in this Silico app. So here we are. Let's introduce this case example of growing a consumer brand. So we're putting ourselves in the position of somebody. It's a very similar position to somebody I happen to know right now, as it happens. 18 months ago, you launched a new premium health drink. Now you're not Procter and Gamble or Coca-Cola here. You're an entrepreneur starting this business up, and you've been going for 18 months. It's a premium health drink targeted at particularly precious people who are concerned about their health and their sports fitness and all that kind of stuff. And you've been selling that product through specialist stores. Okay, so you're not selling it through Walmart, you're not selling it through Tesco. You've targeted stores that are focused on those kinds of consumers. And because it's just you and you haven't got a lot of money, doing the kind of big brand consumer marketing was way too costly. So you relied on simple in-store marketing promotion. So putting discount vouchers through people's doors, putting discount offers on the shelves in the stores that are selling your product. That's the kind of thing that you've been spending your marketing money on. Now, you are kind of geographically limited. There's a limit to how broadly you can distribute your stuff. You're not going to be selling it across multiple continents. And in the region you feel you can reach, you reckon that there are about 200 of these stores that you could reach. And from the sales you've managed to achieve, and from talking to those stores, you guesstimate that there are about 100 potential consumers for each of those stores. Now that gives you a kind of universe of all of the potential consumers you could reach of something like 20,000 people. You could be wrong. I mean, it could be 50,000 or it could be 5,000, but the evidence you've got suggests that it's something like those numbers. What's happened so far? Well, sales have grown. You've kind of done okay for those 18 months. But in spite of your efforts, only a small fraction of those stores are actually stocking the product. And if we chart out what's happened to your sales, this chart shows the history of the first 18 months, where sales have grown to, what's that, something less than kind of 4,000 units a month. And your best estimate, given the limitations you feel you're up against, is that you, with a bit of luck, you might get to 10 or 12,000 units a month being sold by the end of year 3. So that's month 36. But you feel you could reach more consumers and you could get more consumers to take the product and grow sales more strongly to month 36. So that the kind of green dashed line in that chart shows what you'd like to see happen and what you think could happen if you do all this well and get your strategy right and do the right things. We're going to examine just one strategy option here when we get towards the end of all this. So how do we go about this? Well, the first thing is we've got to figure out what is the timescale over which we're looking at all this thing. So if you look back at the chart I just showed you, that is covering a period of the past 18 months and the next 18 months. So that's 36 months in total. And we are looking at it in monthly increments because that's a kind of frequency with which you're tracking your performance. So setting the time scale for how we're going to model this thing is the first thing we've got to make some decisions about. Now, you will not have to do the steps I'm about to show you because I've already done them to create the model that you've now got on your screen. Okay, but this is what I did to get you there. What is the time scale over which we want to look at this thing? First of all, wherever there is history, we should include history for two very important reasons. The first is you have a hypothesis of how the system works and you're building your model to fit that the hypothesis. And if your hypothesis is correct, then the way your model behaves should match the real world. So the history gives you information about how the real world works, not just the outcomes that you get, but everything else that generates those outcomes. So that's the first reason. It confirms how the system works. The second reason for including history is that things that happen in the past already account for what happens today and will continue to account for things that happen in the future. So if we made a very successful product launch 3 years ago in some other world, and we've got a huge number of customers who absolutely love that product today, that event 3 years ago is already explaining what's happening today, and it will continue to explain what happens out into the future. So past events are important. That's why we include history. Include enough history to explain, even with an E on the explain there, what the current outcomes are. Now, what does that imply in practice? Well, for typical kind of large issues for the business as a whole, it's almost certainly going to be more than 12 months. It's very commonly it's 2 years of history because that gives us 2 calendar years of evidence for how the world works, and you might be looking 12 months, 18 months, 3 years out into the future. So it's that kind of timescale for big performance issues. If it's one-off issues like what might happen if we launch this marketing promotion, or what might happen if we try to fix this service quality problem that's just happened in the last 2 months, then you should start the model from before that episode, so you know what was going on before the opportunity arose or before the problem arose or whatever. So you've got a reference for what was happening before the incident started, and then continue it for as long as it takes to resolve the issue or to achieve the outcome that you're looking for. And that would apply for situations like, we've got an increase in staff losses. Why is that happening? Well, go back to a time before staff losses were too high and figure out what was going on then and see what's happened to account for the rising staff losses after that. Customer complaints, things were going perfectly okay up till 6 months ago, and we've seen a steady increase in customer complaints since. So that might mean a model that's only a few months of history and only a few months out into the future. There are cases where you don't have any history. Maybe you're doing a business startup, or maybe this is a new issue that's never happened before. What do we do then? Well, you start from today, but always look for similar cases. It is very, very unlikely that this thing has never happened to anybody else before. So if it is at all possible, look for similar cases to what you're trying to analyze. We call them analogs. Many companies have launched a product before, for example. Many companies have acquired other companies before. So look at what happened before if you have no history for this particular thing you're trying to deal with. What time units should you set up for your model? I've been working in business strategy for decades, and we're typically looking at what's happened over the last 3 years and what's happening over the next 3 years, and then we're doing a kind of quarterly reporting to investors and that kind of thing. Years and quarters are just hopeless. I mean, they are much too big chunks of time. Why are they too big? They're too big because things change faster than that. Things certainly change month to month, week to week, in very fast moving situations, even day to day. And crucially, we can respond faster than that. If a competitor comes out and launches a new product, tomorrow, you're not going to wait until the next financial year before you do something about that. You're going to react within weeks or months. So those are two reasons to look at shorter time periods than quarters and weeks. As I say, monthly, shorter time periods than quarters or years. As I say, monthly, weekly, even daily. So pick short enough time units that the amount by which the situation changes in each period is relatively small compared with its current scale. What do I mean by that? Well, sales, customers or staff numbers change by, rule of thumb here, try to pick time units during which nothing changes by more than about 10% in any period. Clearly, when things are kicking off, you're going to see change rates of 100% or 200% per period. But when things get going, look for time units where things don't change very much from period to period. Pick shorter time units for more operational issues. So if you're looking at customer gains and losses, then that will certainly be monthly. But if you're looking for figuring out what to do with changing rates of customer support calls, that might require a daily model. So the next slide is going to be another of those which I'm not going to spend any time on. It is kind of oriented to those people who are SD experts. I'll come back to it in just a moment, but let's have a look at how these time settings work in the modeling app. So as I say, this is already done in the project that you've got. You don't have to do this, it's already done. This is what you would do if you were setting up a new model from nothing. You go to the top left of the app's menu there and pick the project menu item under project settings. That will open up this window, and in that window you set the start date, the start time, and the time units that you want the model to look at. You can, if you wish, choose real date time units, as I've done here, or you can leave time units undefined. So it just goes in, it just goes from 1 to 50, where you're not saying whether 1 to 50 minutes or hours or days or years, right? Those are options that you have. As I say, there are some details for the technical specialists here, which I won't go into. I'll go straight on. If you can go back to that slide and check out what I passed over there, if that's important to you. Okay, so time to get going on actually making the model happen here. We've set the time scale, we've set the time units. For this model, for this consumer product, we're looking at a 36-month time period, and we are modeling it in months. I'm seeing a question here from Josh saying, "Are there resources for finding relevant history when it doesn't exist in your own history?" In the case of publicly quoted companies, there very often is a limited amount of reported data about what's actually happened to a company's sales over a period of time. Quite often, companies are quite keen to tell you about how successful some initiative has been, and they will give you at least indicative information about how a product launch went. If you're in a competitive market with another company, then you probably know or can estimate with reasonable accuracy what's happened to the sales of a new product they've launched. If you're in a new venture world, it's entirely possible that investors, venture capital providers, can point you to similar cases that are somewhat like your own, and you can fill in bits and pieces of what a possible scenario might be for the start of a new business. Back in my day when I was working in the real world in strategy, we went out and did fundamental research. I happened to work in the restaurant industry, and we would send people out to sit in the car park of our competitors' restaurants and count the number of customers going in. And if you know that, and you know what the prices are for their products, you can pretty much put together what's happened to their revenue. You pretty much know how a restaurant makes profit, so you can work out their profit has been. You know how fast they've been opening units, so you can sketch that out. So you can pretty much replicate your customer's business history with a little bit of research. I hope that's helped a little bit with Josh's question. It's not always possible. Sometimes you've got to make your best guess. Okay, so here we are at step one of this four-step process. And what we're going to do is we're going to create something we call a variable for our product's sales history and objectives. And how are we going to do that? It will be in model one in the project that you've opened. You should find it in the top left corner of the top left of the menu there on your screen. So what you do is you right click somewhere towards the lower right of the workspace. You see this menu come up, which is create a variable. Then you select that item from there, or much simpler, just hit the V key on your keyboard, and this is what you get. When you do this, it's a variable object. What are you looking at here? The first thing is the name. It will default to variable one. You're going to give it a more useful name than that. The circle is the object itself, showing its value at the end of the time period. And below that, there's what we call a mini chart that will show how the item's values change over time. So if you want to have a little kind of spreadsheet analog in your brain here, then imagine that variable one is what's been entered in the top cell of a column of numbers. And what we will do is we will fill that column of numbers with all the values going from month 1 to month 36. But that's what a variable looks like. So let me just switch over and do that for you. Here, as I say, is one I prepared earlier, but let me go through the steps. Let me zoom. So, as I say, right-click there, select Create Variable. If you don't like that, just hit the V key, and the V will make the item open wherever your pointer happens to be on the screen. So, done that bit. What do we do next? We need to give this thing a name, and we need to give it some values. So what we're going to do is click on that variable to open its settings panel. This is the settings panel that you will see. You're going to give the variable name. We're going to leave the formula blank for now. We're going to tell the variable what range of values it's going to have. And then we're going to set a maximum for that of 20,000. So a maximum number of sales for our product of 20,000 units per month. What we're then going to do is we're going to sketch how that that sales rate has changed over time and how it might change going out into the future. Just check I'm at the right step here. And a particularly useful thing to note at this point is that Control Z here undoes any number of steps. Okay, so there's an infinite undo chain in this app. So you can undo as far as you want, and Control Y will redo any number of steps that you want as well. If in doubt, Control Z, go back and try again. Okay, so let's do that. Here's the variable I just created. Just see if I can zoom in the browser screen for you so you can see that a bit more clearly. Maybe that helps a little bit. Here on the left is the one I created earlier. I'm going to replicate that with this one here. So here's the variable. I'm going to call this total sales. I'm going to leave the formula blank. I'm going to set a chart scale for this. This thing here, if you don't check that, it will just auto scale. But we're going to say that we want this thing to go to a maximum of 20,000. And I did say sketch the growth of this sales variable, and you literally do that. So click and hold with your mouse there, drag it across there, and there's a scenario for sales. Maybe you don't like that history. Maybe that's not history's not accurate. Maybe it did something more like that. And you think it might do that. Oh no, that's wrong. Control Z. Let's put that back the way it was, and do that all over again. And you'll notice as we do that, that over here on the workspace, there's a little chart there that does exactly the same thing. And this number here is the number at the end of that time period. If you want to look at the actual values, scroll down, you can roll up, you can hide all of that stuff, and you can look at the actual data. And there is all of the data for the actual values. I'll say a little bit more about where there are two columns here in a moment. But if I change the chart, then the values change. If I change a value, then you can see that the chart changes. So either change the value and the chart changes, or change the chart and the values change. Okay, I hope everyone was able to do that. I hope I'm not leaving people behind already. Not seeing any signs of panic just yet, so I'll assume that that's okay. Right. back to the presentation. So we've now got a variable. We've got a history which we sketched in for its for our actual sales of this product, and we've got a forward projection for what we think might happen over the next 18 months. This is the settings panel. There's the item that's highlighted on the workspace. There's the name at the top. You can put in some extra text there as well, which shows up on the workspace, but it isn't part of the object's name. This is where you put a formula in. Now, this is a really important issue here. I think that I don't know if other system dynamic softwares can do this or not, but Silico enables you to have 2 time series for every item in the model. Why do we have 2 time series? Well, the whole point of what we're trying to do here is to explain the real world. So we should have the real world in the model, and we should have what our model says to compare with the real world. Now, as far as history is concerned, that says, is our model copying history correctly? And as far as the future is concerned, it's saying, is the model telling us how we can achieve the future that we want to achieve? Okay, so that's why we've got two time series. There will come a point, which you'll see shortly, where we can see both time series separately on that chart. And they will also show up on the mini chart on the display. Now, if you put a formula in that box, then the simulated values will do whatever the formula says to do, right? If you don't, the simulated values will copy what we've just sketched in. The item on the workspace shows the final values, and the mini chart shows a matching chart there. This is where we set the chart scales. We can hide that little chart on the workspace if we just don't need it. Let's say we've got a constant value and we simply don't need to see a chart. We can hide that there. I've been very naughty with this model, and I have not documented everything in it, but every note object, every note field for every object should have some explanation in it. We should type in there, you know, where this data came from, why we've formulated the formula the way we have, that kind of thing. So we should always document those items in a note. I already showed you that you can hide those settings so that you can view more data, and down at the bottom is the drop down to see the data values for both simulated and actual values. Now, we can't do this right now, haven't got time, and it's not easy to kind of demonstrate it for you in a way you can actually do it. But it's very likely that you've got historic data. So here is a screenshot of a column from a spreadsheet where I've actually got our actual sales history for this product. Select and copy those cells. They must be organized vertically with no formatting. Go to the model. Open that settings panel, go to the data at the bottom, select the first cell in the actuals column, and paste that data into this that you copied from the spreadsheet into that column. There is a way of automating links, of setting up tables within the app to automatically fill those actual data columns, but that's kind of beyond our scope for this afternoon. If there's no formula, the app simply says, you haven't told me how to calculate this thing, so I'm simply going to assume that the actual values are the simulated values. We'll change that coming up quite soon. And there's the time chart changing to match the actual values. So now we've got the variable, we might want to actually show a larger chart for this. So we're going to create a chart for that sales objective, because this is going to be our key thing we want to see. We hit C on the keyboard to create a chart at the pointer location, or select create chart from the right click menu. And what we're going to do is going to drag a connection from the chart into from the variable into the chart. The way we do this is you click and hold the pointer in a cloud that will appear if you move the pointer close to the variable. We drag the link arrow until it hits the chart. Now, if the slideshow works well, you should be able to play yourself a little video here. I'll just play this up. That shows how it works. Click and hold, drag the arrow until it hits the chart, and the chart is now populated with the data from your sales. Okay. Let me do that. So right click here, create a chart, or simply hit the C key, drag from there, and we've now got a large scale chart, and we can do other things with this chart, like put other variables in it and that kind of stuff. So good news, we've done step one of the process. We have created the time chart for the desired outcomes, including history. And that is what you'll see if you click on model one in the project. What you're seeing in that chart is you're seeing 18 months of history and 18 months of the future. And for the future, what we sketch there is what we think is likely to happen given what we know about how our business is working. We could have done some spreadsheet work or whatever to produce a forecast trend or something of that kind. Just as likely, it's as easy to sketch that future chart. And that's actual historic values there, if we've got them. So we're now at step two. We're going to add these things called stocks that drive those outcomes. And we get to those things by asking what quantitatively causes those outcomes. And that is going to discover for us these things called resources, customers, staff, those kinds of things. And let me build on this issue that what we want is local numerical, very kind of real world, hard causal explanations for every item. So we are not looking for what people typically want to look for, which is kind of big system-wide explanations for what's going on. So if you're interested in what's causing the crime rate, you might have some view that it's unemployment that drives crime. If only we'd get the unemployment rate down, we'd have less crime. If you wanted to know what drives sales, oh, well, it's our marketing, isn't it? It's our marketing that drives sales. Well, those are not local, concrete, numerical explanations. I can't write an equation that says crime equals X multiplied by the unemployment rate. I can't write an equation that says sales equals X multiplied by my marketing spend. What the kind of explanation we're looking for is something of this form. How many crimes per week are being committed? The number of crimes being committed per week is caused by the number of criminals who are committing crimes and the frequency with which each one of those criminals commits a crime. Where does my sales come from? My sales come from how many customers have I got, multiplied by how many sales per month does each customer give me, whether it's for this consumer brand or whether it's for how many cars Toyota sells or whatever. It's a local numerical causal explanation. So this is the question you keep asking at every single step. What causes this item? To be more precise, on what other items does this one directly depend? And to be more precise still, what other items' values do I need to know in order to calculate or estimate the value of this one? Right? So that's what we mean by what causes this item. So what items' values do we need to calculate our product sales? Well, how many stores are stocking my product? How much of each of my product does each store buy each month? So our sales in units per month is how many stores have we got multiplied by how many sales per store. Stores are one of these things we call a stock. We got, let us say in a certain month, we start with 25 stores at the beginning. We win 5 stores, we lose 2 stores. So at the end, we've got 28. We'll say more about this at step 3, but for now, let's just recognize the fact that stores in our product model actually is one of these things called a stock. How are we going to do this? Well, first of all, we're going to give ourselves some space in the model. We're going to click and hold on the object and the chart, and we're going to drag them to the lower right of the workspace. There's a little video you can play for yourself when you run the slide chart, but I'll demonstrate that to you right now. Oh no, it's going to demonstrate it to you anyway. There we go. Drag around them, click and hold, and drag it down to the lower right. So let me do that for you. First of all, let me kill these things that I created for demonstration purposes. I'm going to drag around these things, and I'm going to pull them down here to the lower right. There we are, done that. What we're going to do next is hit the S key on the keyboard to create a stock object, or create it from the right-click menu. And then we're going to click that stock to open its settings. Let me do that. So over here to the right, I'm going to right-click and choose Create Stock, or I'm simply going to hit the S key. And I'm going to click that thing, and that's opened the settings panel on the right-hand side. What we're then going to do is give that stock a name. We're going to set its chart scale. In this case, it goes up to, the chart scale goes up to 200. You remember I said we thought there are about 200 stores in the region that we're serving. Now, given everything I just said about stocks, the first thing we're going to do is actually we're going to tell this stock, just forget that you're a stock for a moment, please, and behave like a variable. We'll undo that later, but that's an important thing we do at this stage. And then guess what? We're going to sketch how store numbers rise. We're going to make them rise to about 100. So let's do that. There's the stock stores with the product. Going to make that go from 0 to 200. We're going to say to this thing, please behave like a variable just for now. And this is what we think might happen to the number of stores that stock the product. And just as with the variable, that's done the same thing. Okay. Now, remember I said that our sales must be the number of stores multiplied by the amount each store sells each month. So we're going to create a variable for sales per store. We can move its name around the object. We can drag the chart out of the way. We're going to give it a name, and we're going to we can also give it a stub. I happen to use it to put units in quite often. We're going to set a chart scale here of 0 to 200 units per store per month. And again, we're going to put a sketch in there. So let's do that. Click and hold on an object to move it. We're going to put a variable here, drag that around there. And this is sales per month per store. Ooh. Forgive my typing errors here. We're going to make that go from 0 to 200. And this one we think is going to go like that. And it seems to have stalled at around 100 units per month per store. So those are the items that we think account for our sales. Now, what we need to do is figure out whether we've actually got a valid explanation for that sales rate. So what we now need to do is connect the objects in order to calculate those sales. The things that we just added are called source objects. They are things that we believe are causing the outcome we're interested in. We're going to move the mouse pointer until it is close to, you see the mouse pointer here is close to this variable, and a cloud thing appears. We're going to drag the mouse pointer away from that variable until it connects with the target object, and repeat those steps to connect stores to sales. And here's another little video you can play to show how that should work. Click and hold in the cloud, drag until it connects. So this is what you should end up with. Let me do those things. Click and hold, drag it until it connects, click and hold, drag it till it connects. That says our sales are caused by those two things. Those red links, by the way, indicate that the source object, each of those source objects is not yet used to calculate the target. So we're not using those things to do any calculations yet. So now we need to do that calculation. So we click in the object we want to calculate, and we start completing the formula at the top right. First of all, we click the blue item in below the formula box that says one of the things you can use in the formula is the number of stores stocking the product. So you click on that, and that puts it straight into the formula. You don't have to type anything. You hit the multiply key. You then click on sales per store to add that to the formula, and that completes the formula. Let's just do those steps. Click that item, the sales we want to calculate, and it's the number of stores multiplied by. So you see that as soon as I click stores with the product, that link went black to say you're now using that in the formula. I click, that's put that in the formula as well. And we've now completed the formula. Now, you remember me saying that there are two time series for every object. There are the actual time series and the simulated time series. The dotted line here is the actual data that we sketched in with our mouse when we created our sales in the first place. And the solid line is what you get if you calculate it from these two input items. Let me just show you how that changes. What happens if I made a hopeless guess for how much each store sells? So there you go. I've changed my assumption about sales per month per store, and I've got a completely different simulated result for our sales compared with the actual. So that was a bad idea. Let me hit Control Z and put it back the way it was. Okay. I will skip over this slide because this is only explaining what the general principles about what I've just demonstrated. I've also just done this for you. I've changed the schedule, the formula, to show you that you end up with a very different result. So one of the things we do, this is an extremely useful feature here for working out the values of a source object that you don't actually know. Let's say that you did know what your sales were, and you did know what the number of stores stocking the product had done. This is how you would figure out what sales per store must have been. Obviously, you could simply do it backwards by dividing sales by the number of stores, and that would tell you exactly what that number is. But there will be other situations where there is an unknown variable, and this is how you discover what its values might have been. By doing that sketching until the simulated values match the actuals. So we know this stock's value, how that's driven sales. We've now got to know what drives that new unknown item. Keep asking that same question. What items values do I need to know to calculate sales per store? Well, how much does a store sell? The amount it sells is how many consumers use the store and how much do they buy. Multiply those two numbers together, and you end up with that explanation. And consumers is another example of one of these things called a stock. And you discover the average purchases per month by asking people, right? Like, how much did you buy each month? It's a relatively simple piece of research to do. So we go through the same process again. We create that stock for the consumers per store. We name that stock. We set the scale for that stock of consumers per store. How do we know what the scale is? Well, we know that sales per store is about 100, and we know that purchases per consumer is about about 5, so consumers per store must grow to something like 20. So set a scale of 0 to 50, and that tells us what it is. Don't forget to make this thing behave like a variable just for the moment. Okay, and we add a variable here for the purchase rate. We give it a constant value of 5. So there's its name. And here we've actually put a formula in. We haven't sketched what's happened to the purchase rate per consumer. We've actually given it a value of 5. We've told it we're not interested in seeing a little chart here under the purchase rate. We think it's about 5 and we don't need to see it changing over time, so we hide that chart. Again, we link those objects, we create the formula, and we change the sketch for how many consumers we've got until our simulated values match the actuals. So step 2 is now done. Let me go to the model. What I've done here, I did all this in model 1, right? But actually the end result of doing that is all in model 2. If you go to model 2, that is everything that we've just done. Control A selects everything. You can move things around the screen. So there we go. You can see everything that you want. So those are the 2 stocks. That's how they drive the performance outcome. So what do? We kept asking what causes this. So at step 1, we completed the history and the likely future for our outcome. And at step 2, we identified the stocks driving that outcome at all times. So there is in the pink, I've highlighted the kind of causal pathway from the things that are driving the outcome to the outcome itself. And it's in model 2 in the project. Now we're ready to do step 3, which is the flow rates, changing those stocks. And we're going to quantify those. Remember I said that this thing called a store stores is a stock. What causes that number? Well, it's the number that we had last month, plus whatever's been added minus whatever's been taken away. What's the maths here? Well, stores at the start of next month is stores at the start of this month, plus what's been added minus what's been taken away. Good news is you don't have to write that formula at all. Because this is simply how the real world works, the software will do this for you. And it applies to every month. So this is a stock that accumulates over time. This is what we call a flow rate. It's like a pump pumping stuff through that pipe into the tank of stores. And that's a flow rate draining that stock like a pump and a pipe. Now, this is really important. The relationship is what we call axiomatic. It simply is how the real world works. There is no other explanation for the number of stores. It's not an opinion. It's not a statistical finding. There is no error term. The number of stores is precisely 28. It's not 28.35 recurring or anything of that kind. It simply is 25 plus 5 minus 2. So we're now going to add those flow rates to our model. And we're going to add flow rates for both stores and the consumers. There could be loss rates for both of these, but for simplicity, I'm going to bypass that step for now. How do we do this? We add a flow object by hitting the F key to the left of the stock. We click and hold the arrow head and drag that until the arrowhead sticks to the stock. So let me just play the video to show you that. Click the flow, give it a name, set its scale, give it in this case, I'm going to give it a formula. We'll give it a better formula later on, but for now, I'm just going to say it's 1. And we'll see in a moment. I will demonstrate this in the model right now. So over here to the left of the stock, I'm going to add a flow for the number of consumers, 1. I'm going to drag it until it hits the stock. New consumers per month per store. We going to give it a scale of 1 to 3. And now we're not going to sketch it in, we're going to give it a value, and its value is 1. Now, here's a thing, we've given it a value. This stores thing should be reflecting that, but it's not done anything. Well, if you remember, we told this thing to act like a variable. Now we're going to say, stop acting like a variable and start acting like a stock. Now, if you're acting like a stock, you're going to start at the initial value, and you're going to do whatever the flow told you to do, and the flow told you to increase by 1 every month. So that's what that does. It goes up by 1 every month. We need to force it to start at a value of 0, and you can see it matches except for the end of the period. So here's what we've done. We've given a formula for the stock. We've unchecked its act as variable toggle. We've simulated values start at 0 and grow by 1 per month. We've now got a difference between the simulated and actual values, and the model will use the simulated values for anything else you want to calculate. We go through the same process to add flow rates causing each stock to grow and decline. We add a flow to the left, name the flow stores 1 per month, set a scale for that. That could go up to about 10. There's no formula here. And we're going to sketch the number of stores 1 per month, rising to about 4. Click on the stock, tell it to act like a variable. This is how many stores we win or lose. And is that a good explanation for how the store numbers grow or not? Well, the solid line is quite close to the dashed line, so it's a reasonably good explanation. Now, we often know the quantity of a stock, so this is a useful way to work out what the flow rate would be. So let's say we know how many people we've had each month, and we know how many people we've hired, but there's a loss rate of how many people have left. So this is a way of figuring out what that is. You play with the flow rate to make that happen. And you'll find the result of that in model 3 in the project. So here we've got that plus 1 per month for each number of consumers being won by each store. Down here we've got the flow rate of stores being won, and you'll notice here this is the actual number of stores we've won each month. So 1, 0, 2, 1, 2, 0, 3, 1, 3. So this is a time series of the actual stores won per month. So it must pretty much match the actual number of stores that we've got. Let me just pause for a quick moment to see if there are any questions at this point. I'm not seeing any questions, so I will crack on. This either means that everybody is completely mystified and has got a clue, or it's reasonably clear and you're following what I'm doing. If, by the way, you've got lost trying to copy what I'm doing, what you can do is you can just click on Model 3 on the left of your browser window here, and start from here. So if you've got in a bit of a mess trying to copy all this, don't worry. Click on Model 3 and start from here. Now, we've done step 3. There's step 1, the history. There's step 2, how the stocks are driving that history of outcomes. We've done step 3, how the flows are driving their stocks. Now, and we've got real numbers. So what we need to do now is figure out what's driving those flow rates, and it will turn out to be existing stocks. What causes those flow rates? Keep asking that same question. What causes that? What causes that? So what drives the number of stores won per month? Well, it's the number of sales calls we make on those stores multiplied by the fraction of those sales calls that succeed in winning a store. There's no other reason for stores to be won. At this point in time, they're not kind of spontaneously calling you up saying, I'd really love to stock your product. They might do at some point in the future, but not yet. We have to sell to them. Drag the stores and the store win rate to lower left to make space. We're going to add a variable for sales calls. We're going to add the fraction of successful calls that result in a sale. And we're going to sketch that success rate. Let me do that for you. Drag this thing out of the way. Sales calls per month. We're saying that's 20. That's we haven't got time to do lots of other things except make sales calls. And then we need this success rate. And we believe that that is going to start quite low and it's going to go higher. We're going to connect that to the flow rate there, and we're going to make that flow rate. We're now going to calculate that instead of estimating it. And that's going to be how many calls we're making multiplied by the success rate. And you can see that gives a completely ridiculous, it's not ridiculous, but it's come too high a success rate. So we've estimated that thing too high. We're not as successful at that. And that, of course, is not a success rate percent, it's a success rate fraction. So we've now got a not too bad explanation for how fast stores are stocking the product. So now what we want to know, we've got to keep on drilling back and ask ourselves the question, why that success rate? Why is that the success rate? This is the step we've just done. You can play through these steps yourself. Why this fraction of successful calls? Well, it takes more than one call for a store to say yes. They don't say yes first time. A few might be willing to try a new product the first time you call them, but many more will say yes if they expect good sales. And we already know what's happening to sales per store. Now, in this case, there is no formula to calculate how sales success will vary as sales per store changes. But this is a case where we can estimate the relationship. Now, you remember this slide, I said, what causes this item precisely? What other items values do I need to know to calculate? And I did say, or estimate the value of this one. And this is going to be a case where we estimate the value. And we're going to look up how sales success depends on sales per store. We're going to hit L on the keyboard to add a lookup table. We're going to name that lookup. This is not a time chart. This is what value of Y do we get for any value of X, and what is the range going to be for sales per store. We're going to sketch that success rate relationship. So let me just show you how that's done. Actually, in the interest of time, I'm going to move on and show you these items in the next stage of the model. So this is the success rate that we're trying to explain. We know that it depends on how much sales per store any store owner can expect. And this is what we call that lookup function. And we can change the shape of that. So if sales per store are 200, about 60% of our sales calls will be successful. Over 300, then 80% of our calls will be successful. If sales per store are only down here at 100, then only 20% will be successful. That's a lookup relationship. And the formula in here is how that is calculated. Let me just delete that formula and show you the structure of it. Click on the item which is the link to the sales success. It already says, I'm going to look this up for you. What do you want me to use to look it up? I'm going to look it up from sales per store. There we go. Now, that's not the only thing causing the sales success. The other thing causing the sales success is how many stores are there out there. If we've already won them all, then we're not going to win any more. There aren't any more to be won. So this structure over here on the right, on the left, says how many stores are there? What is the remaining number of potential stores? What does that do to the success rate? So it basically takes this number and it says, I'm only going to be successful a fraction of that number. And that is the stores, the actual stores win rate that we get from that. So that you can go through these steps with the slideshow yourself. This is the bit that calculates the sales success rate if there were an unlimited number of stores, but there isn't. There is a limited number of stores, and that potential limit will slow down the rate at which we win stores. And this is the structure that deals with that. We add these items. This slide will tell you exactly what to put into the formulae for those items. And we've now defined, we connect those up and it tells you what the calculations are. So if there were an unlimited number of sales calls, this is the success rate that you would have. And this is the lower success rate you have because there is a limited number of stores. This is a very common thing in business models, not just business models, but in models in other fields as well. There is a limit to how fast things can grow because there is some limited potential that you can exploit. Okay. We've basically completed those steps. So let me point out what we've done here. Go on, go on, go on, go on. I'm just moving on in the slideshow. Just bear with me 1 second. So when you've completed these steps, this is the structure that you end up with, and the slides I've kind of jumped over will take you from where we were in model 4 to the complete model of what's causing our sales. Do add notes to highlight decisions. What have we done here? We've shown that the stock of active consumers is driving the rate at which we win stores. We've shown that the stock of remaining stores is limiting that growth rate. We've shown that the stock of stores is helping to drive the consumer win rate. And we've shown that the stock of remaining consumers limits that consumer growth rate. We've now got a feedback structure here, and later slides in the deck that you get will go into exactly what that feedback structure is. But here are the causal links explaining the outcomes that we want here. Now let's explore some sensitivities and strategies here. And I'll do this in the model rather than go through the slides to explain this. Where are we? Here is our model, and we'll go to step 4. On the left here, there's a scenario option. You click here to add a scenario. I've already created one, and the scenario I'm going to test is to increase future promotions. So in this scenario, the model is basically locked up now. I can't move anything or change anything. What I can do is I can say, what happens if one of these items changes? So I click on a thing that I want to change. I've told this one that the promotion spend was $2,000 a month. I now want it to increase to $4,000 a month. So I'm going to step it up to $2,000, to $4,000. I'm going to add a step of 2,000. I'm going to do that at time 19. And if I do that, I get the green results here and not the blue results. That's how easy it is to add a scenario, and there's full details in the slide deck on how exactly that works. So in this scenario, we decide to increase the promotion spend, we win consumers faster, our sales per store grow faster, and because of the feedback with winning more stores and winning still more consumers, sales per store grow faster than in our base case, which is the blue. Even in the blue case, the model is telling us that our forecast, our likely forecast in the dashed line for the future, was a bit too pessimistic. If the system works as we think it does, then we're likely to get growth in sales anyway. So let me just go through the benefits of this agile process. So this is that process. This is just a single image of that process. First of all, what do I mean by that thing that says go round that process as many times as necessary until you're satisfied? Well, until all the model factors values over time appear to be explained, right? You can stop when you've reached that point. Just check with anybody else involved that there's nothing else missing. But when you've got a good match between the values of all the items in the model and the real values that you've got, then you've got a good explanation for the outcomes. Now, go right back to the start, just that very first step of moving from step 1 to step 2. We already got useful insights out of that. Because we use data and because we use that actual simulated comparison all the way through, we know at all steps that the model is valid. If there's anything, if the simulated value doesn't match the actual, something's wrong, go fix it. And the process discovers the feedback based on evidence. We're not discovering feedback by asking people what they think the feedback is. We're actually discovering it for real. And remaining slides in this deck do expose exactly what those feedback structures are here. They're not very complicated. There's a reinforcing feedback between stores and consumers, and there is balancing feedback limiting the growth of both of those stocks. Limited population of consumers and limited population of stores. So let me stop at that point, and just go to next steps, which I'll put on the screen. Now, Megan is going to tell me that we're out of time. Sorry, I should not have stopped sharing the screen. Well, I hope you'll give us a few minutes grace, Megan, for at least 5 minutes if anyone has got questions at this point.
That's fine. There is one question. Would agent-based modeling complement SD in dynamic business modeling?
Okay, for those who don't know, agent-based modeling works by modeling what happens to individual entities, in this case, individual stores, individual consumers. And it is very, very powerful when you need to know what happens to individuals, especially when there are geospatial issues involved. I was listening to a podcast today about complexity, and they were talking about what complexity models can do with agent-based modeling, and they were talking about issues like how crowds move through a building if there's a fire emergency, something of that kind. If you've got a geospatial thing going on, you have to use agent-based modeling. You basically can't use SD modeling for this. The big advantage of SD modeling is, as I hope I've demonstrated this afternoon, you get a very long way in a very short time. I think my record is with the CEO of a quite substantial new venture. We built a complete business plan model with him, complete with all his data for the first 2 years of his operations in 2 days. So you get very long way, very fast with agent-based modeling. But if you look for it, there are people who specialize in combining these methods. If you do a hands-on Google Scholar, you should find that out. Oh, the podcast I was listening to happened to be a BBC podcast about complexity theory. It won't tell you anything at a very high level of sophistication. It was for a podcast for the general public. How do you know how much to expand the model? Well, I tried to explain that in terms of you can be reasonably confident that you've captured everything when everything in the model that you've got is already connected to something else, and when its simulated values match the actual values. It's still possible that there are things missing, either that are there in the real world already, or that may jump up and bite you sometime in the future. Like, next month your competitor launches a new product that you weren't expecting. That there can be things of that kind that aren't there. But when you've got a good match between the things that are in the model and the things that are in the real world and what the simulated values are doing versus the actual values, you can have reasonable confidence that you've got a good match and you don't need to go any further. Would data science skills lead to better modeling? Absolutely. There's all kinds of mathematical methods you can use to optimize these models, to give you a kind of statistical indication of the goodness of fit between your model and reality and so on. Is there a way to export these models to Stella or Vensim? Currently, no, but we're working on it. And vice versa, by the way. Are there tools to connect real-time historic data into these types of models? Yes, this can already be done. It's beyond what we could do this afternoon, but it can be done, yes.
That's it for the questions. I want to thank Kim Warren so much for this presentation today and for all of you for attending. This has been a really insightful webinar. And
thank you for sticking with me with all this stuff going on.
Yeah, we will be sending out a thank you email with a survey as well. And I will also be uploading this recording and the slides to our blog where the seminar recording can be watched afterwards if you want to access it again. So that will either happen this week or next week when Fernando is back. Thank you, everyone. So someone asked about the 6 attendance codes. So you actually have to watch 6 of the seminars in this System Dynamics for Business Innovation series in order to be able to access that certificate of completion. So the codes are mentioned either at the beginning or the end of those seminars. All members have access to seminar recordings on our seminar series page. Let me just send a link to that seminar series page quick. And so just take note of those, and then you can fill out the form to get your certificate of completion. Yes. Thank you, Francisco, for that link. And then I also included one for the regular seminar series. And then, as I mentioned at the beginning, we are providing a discount on memberships for all of those who are first-time members. You can get 30% off till November 30th at any membership tier. So use the code BIZ30, B-I-Z 30 at checkout I sent it in the chat just now where you can click to join as a member and then use that coupon code at checkout in order to access your membership discount. And that will allow you to see all the seminar recordings, because Kim has really offered a lot of seminars this year on various different topics. And this can be really useful for those of you in the business world who are interested in learning more about modeling for business. Thank you.
Thank you, Megan.
Kim, do you have anything else?
I think we're out of time, right?
Yes.
Okay.
All right. Thanks, everyone.